Let's look at distance and fractional distance. All right, so let's look at number 1. Number 1 says Mike and Josh are racing to Buc-ee's. Obviously, I'm going to pick my favorite place to go. Mike is located at -2.4, and Josh is located at -5, -3. And Buc-ee's is located at -1.3. If Mike and Josh are traveling the same speed, who will reach Buc-ee's first? So what we're trying to figure out with this is who's going to get to Buc-ee's first. Now, in order for us to figure out who's going to get to Buc-ee's first, we need to see who is the closest to Buc-ee's. And the reason that we're going to see who the closest to Buc-ee's is because that's going to be the shortest distance to travel. So that's going to be the shortest distance. So let's look at what we have. All right. We've got Mike, Josh, and Buc-ee's. All right, so I'm going to put Buc-ee's right here. Buc-ee's is at -1.3. These are not going to be accurate based on where they would be on the coordinate plane. I'm just going to say that right now. We have Mike, who's over here at 2, -4. And we have Josh, who is over here at -5, -3. Who is going to get there first? Okay, I want to know, is Josh going to get there first? Or is Mike going to get there first? So, what we're going to do, I'm going to find the distance. So we're going to use the distance formula. And the distance formula, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to use the distance formula to figure out how far each of these guys is from Buc-ee's. They're going the same speed. So whoever's closest is going to get there first because they're going the same speed. All right, so let's look at the first one. Let's do Mike first. So we're going to use Mike. So I'm going to do my distance formula, and I'm going to kind of abbreviate it a little bit. So I always write my formula with my symbols first. Then I go back and plug in. What are my 2 x coordinates between Mike and Buc-ee's? Because we're trying to figure out how far Mike is from Buc-ee's. So 2 and -1. So I'm going to plug in 2 and -1. Those are my x's. Then I have my y's, which is -4 and 3. So -4 and 3. Okay? If I continue on, the minus and negative becomes plus. I end up with 3 squared plus, 3 squared plus -7 squared, because you got -4 minus 3. So you end up getting the square root of 9 plus 49, which is the square root of 58. So square root of 58, that is where we are that's how far away Mike is from Buc-ee's. Square root of 58. And that's going to come out to close to 8, 7 point something. So let's check out the other one and see what we got. All right, so now I'm going to look at Josh's distance from Buc-ee's. So let's do Josh's distance. So I'm going to come up here. I'm going to do the same thing. This is Josh. We're going to look at Josh's distance from Buc-ee's. I'm going to write the formula, everything except for what I'm plugging in. And let's plug in. What are my 2 x's? -5 and -1. So I'm going to plug in -5 minus -1. And then my 2 y's are -3 and 3. So I'm at -3, +3. Okay. I've got a double negative there. I've got -5 minus -1, that becomes plus. So -5 plus 1 is -4 squared, plus -3 minus 3 is -6 squared. So I've got 4 squared, -4 squared, which would be 16, and -6 squared, which would be 36. So that's 52. So Josh is the square root of 52 away. And that's about 7.1. So if you look at it, Josh is going to get there faster because he is closer. He's square root of 52 away, which is about 7.1, and Mike is square root of 58 away, which is closer probably to about 7.6. So we'll go ahead and we'll figure out, I'll use a calculator, and let's figure these out. So we'll do square root of 52. That's about 7.2. So that's where Josh is. He's about 7.2. And Mike is 7.6. So Josh is closer. He is going to win the race. Okay, so let's look at number 2. We did number 2 in class. Determine which two sides, if any, are congruent. You must show your work. Okay, congruence has to do with length. So once again, we're going to use the distance formula. Okay, so I'm going to use the distance formula here to establish the length of these segments. Okay, I'm going to use the distance formula. x2 minus x1, y2 minus y1. In this particular instance, we're wanting to establish that 2 of these segments are congruent. Well, if I look at the picture, my most likely candidates are going to be these 2. So I want to see if I can establish that AD is congruent to BC. So that's the question. So let's do BC first. All right, we're going to find the distance from B to C. All right, I'm going to rewrite my formula. All right, and what are my 2 x coordinates for B and C? -1 and 5. So I've got -1 minus 5. Those are my 2 x's. My 2 y coordinates are 4 and 1. So I've got 4 minus 1. So as I move down to solve this, distance from B to C, -1 minus 5 gives me -6 squared, plus 4 minus 1 is 3 squared. And then I'm just going to keep on coming here. -6 squared is 36, because when we square a negative it becomes positive, plus 9. And that equals the square root of 45, which equals about 6.7. Okay, so we've got square root of 45. We'll confirm it, 6.7. All right, so that means this one is 6.7. So in order for them to be congruent, AD should also be 6.7. So let's find AD. All right, so I'll use a different color here, and let's find AD. All right, AD, if I plug in, for AD, I'm going to plug in my 2 x coordinates for A and D, -4 and -1. So I'm going to have -4. Ooh, so it's kind of running out of ink. And -1. Sorry, that's kind of hard to see. If we can toss that one. -4, -1. And then I've got my 2 y coordinates. I've got 1 and -5. So if I follow through with this, and I look at AD, I've got the square root, I've got a double negative, becomes positive. -4 plus 1 is -3 squared. Plus, I got a double negative again, so 1 plus 5 is 6, 6 squared. So the distance from A to D is the square root of 9 plus 36, which equals the square root of 45, which is equal to 6.7. So the answer is yes, they are congruent. AD is congruent to BC. The last one on this page is going to be fractional distance, number 3, and we're going to determine the point that is 2/3 of the way from point B to point A. So my starting point is going to be point B. That's where I'm going to start. And I want to go 2/3 of the distance. So the first thing that I want to establish is that when we do fractional distance, we're not using the distance formula, okay? We're going to look at the distances based on actually a right triangle. You can form a right triangle here. So I'm going to fill this out using this right triangle. All right, so I'm going to start at B. And notice it says from point B to point A. It's important where you start. So B is at 2, -3, and A is at -3, 4. And we are looking for a point in between them. We're looking for a point in between them that is 2/3 of the way from B to A. So in order for us to solve this, we have to look at a couple of things. We're going to look at the x values, and then we're going to look at the y's. How do I go the full distance from B to A? How did I get from 2 to negative 3? Well, I subtracted 5. So that means I went to the left 5 units. Okay, that's the full distance. Remember, we're only going to take 2/3 of it. So I don't want to go the full 5. I don't want to go 2 and then subtract 5. I only want to subtract 2/3 of 5. So what I'm going to do is I'm going to take 2/3 of 5, and you can put -5 if you want to help you with direction. I get 10 over 3, which is 3.3. So instead of going that way 5, I'm only going to go that way 3.3. So if I start at 2 and I go 3.3 that way, that means I'm going to subtract 3.3 instead of 5. I end up at -1.3. That's my x-coordinate. So now let's do the y-coordinate. How did I get from -3 to +4? Well, I added 7. So I went up 7, since this is your y value. But I don't want to go the full 7. I only want to go 2/3 of the way. So I'm going to take 2/3 of 7, and I get 14 over 3, which is 4.7. So instead of going up 7, I'm only going to go up 4.7. So instead of -3 plus 7, it's -3 plus 4.7. And that puts us at 1.7. So your answer is right here. Over -1.3, up 1.7. That's your point P, and that's about right. That's the fractional distance. That's 1/3 of the way. So that's page 1, or page 2.